In this video lecture, I will be covering the last topic of time value of money, which is your nominal interest rate and your effective annual rate. Till now, all the questions that you have done assume that interest was compounded once a year, which means that the interest was being paid only one time in a year, which is called your annual compounding. However, in reality, interest does not have to be always paid once a year. It can be paid after every 6 months, which is semi-annual interest payment. So if it is semi-annual, you will get interest 2 times in a year after every 6 months. Similarly, interest can even be quarterly, which means that interest is being paid after every 3 months 4 times in a year. And banks generally pay interest more than once a year. Virtually all bonds pay interest semi-annual, and most mortgages, student loans and auto loans require monthly payments. So it is very important to understand how to deal with non-annual compounding. So basically for that you can use the same formula. So I'm going to cut this and I'm going to write the same formula. There's actually some value, some word missing over here. This is m divided by n over here, or sorry, n divided by m. So I'm going to write it again. 1 plus r divided by m, not n and m, sorry. And over here we have m multiplied by n. This is actually the same formula that you have studied, but it is catering to the frequency of the compounding as well. A simpler version that can be used later on is that I tell my students that there are 2 steps whenever the compounding period is different. Number 1 is that whatever is the rate divided by the compounding interval. So m represents the compounding periods per year. That means if it is semi-annual, you have 2 compounding periods. If it's quarterly, you have 4 compounding periods. If it's daily, then you'll have 365 compounding periods. So the first step is to divide your rate by m, and the second step is to multiply your n by m to get the new n value. Once you have done this, you can actually use it in the same formula that you have studied so far. This is what's happening over here as well. Rate is being divided by m and n is being multiplied by m. So you can either do it in the formula, or if you want you can do it separately and then plug in the new r and the new n in your formula over here. So let's look at an example. How are you supposed to do this? Bank compounding quarterly, how much we will have after 3 years after depositing 1000 at the rate of 15%. So you need to find out the future value over here. But the bank is compounding quarterly. Quarterly means that interest is being paid 4 times in a year after every 3 months. So let's make our data set. We know that the present value is 1000, the r is 15%, the n is 3, and the m is 4. The compounding periods are 4. So what is the future value? You can use the future value formula. But first you should divide your r by the compounding period. So 15% divided by 4. This is 3.75%. So this is your new rate now. And the other step is to multiply your n by m. So if you multiply 3 by 4, you get 12. So the interest that is being paid in each period is 3.75%, because in the whole year the interest being paid is 15%. But in 1 quarter it is going to be 3.75%. Similarly, there were 3 years, but in each year the interest is being paid 4 times. So in total there will be 12 interest payments. So now you can use it in the formula. Present value is 1000, 1 plus r, which is 3.75%, and your n is going to be 12. So if you solve this, your answer is coming 1 555.45. This is how you can cater to any kind of question that has a different compounding period. Similarly, if you want to use this in your annuity questions, again you will have to follow these two steps. So if you have a question that uses annuity, again divide your interest rate by the compounding period, multiply your n by the compounding periods, and you can use your annuity formula as it is with the new r value that you get from this and the new n value that you get from this. Now moving ahead, there are some terminologies that you should be aware of. The nominal interest rate is the